Okay, hi everyone, and welcome to the second session for the USACO Bronze programming class. So again, today we're going to be going over a specific topic, but before we do, I did not finish, yesterday I did not fully finish going over the entirety of the first lesson. In particular, I didn't finish going over loops. So I'm going to spend a few minutes quickly going over loops first. So yeah, let me see if I can share my screen real quick, and then we'll get started. Okay, so yesterday I did not finish fully getting to go over loops, so we're going to quickly do that. Anyways, I'm going to quickly cover for loops one more time because I think that for loops are pretty important to understand what exactly is happening. So this is a for loop, and this is the way that it works. Okay, so what exactly is going on here? So as we mentioned before, yesterday, when we declare an integer array like this, it creates like a list of 10 numbers because we have int r10 here. So what exactly is going on in this for loop? Well, what's going to happen is that there's 3 parts to a for loop, and we see all of them here separated by semicolons. There's the variable declaration, the out of bounds condition, and the incrementer. What specifically happens is so in this case, we've declared I equals 0. Then after that, so whatever's in these parentheses here is the code that we're going to keep on running over and over again until the boundary condition, which is I less than 10, has been met. And in this case, and then after each time we run the code that's in here, we increase, we run the code that's written here by the incrementer. So in this case, it's I++. So what specifically is going to happen is that we're going to, like in this specific case, we start off by declaring the variable I equals 0. Then after that, we check, is I less than 10? The answer to this is yes. So we run the code one time, and we read in ARR0, or the first number in the list. After that, we're done running the code. So we run the incrementer code, which is I++, so I increases by 1 to become 1. Now we check the boundary condition again. Is it true that 1 is less than 10? The answer to this is again, yes. So we run the code, and we say, okay, now we read in ARR1, or the second element in the list. And then we're done. So we've now run through all the code in the loop once again. So we run this incrementer code once more, I++. So I goes from 1 to 2. 2 is still less than 10. So 2 is still less than 10. So as a result, we now run cin ARR2, or to get the third element of the list. And then this keeps on going on and on and on until finally we get to a point where I is equal to 9. When I is equal to 9, we say, okay, we run the code again to get cin ARR9 to read in the 10th element of the list. And then after running that, we're finished with everything in the loop. So we run I++, which is the incrementer, to get 9 increases by 1 to go to 10. And finally, we check, is 10 less than 10? The answer is no, it is not. So now that the boundary condition has finally been met, we stop running the loop and we move on. So that's sort of how for loops work. I have a question in the Q&A which says, what does cin mean? So cin pretty much just means that cin means that we're reading in a number. So for example, if we have an integer x, and we wrote cin x, and then we printed out x, so c out x, then we have an integer x. So like cin allows the computer to read it in from user input. So cin x means that we read it in. So you see that what the computer just did is it first declared that x is an integer, then we wrote cin x. So what it does is it waits for me, the user, to type in a number. So I just typed in 5. So after I typed in 5, the computer assigned x equals the value of 5 because that's what I typed in. And then after that, c out just means we output it. So now the computer knows that x is equal to 5, so it prints it out, and it prints out 5. So yeah, that's what happens. Okay, so that's sort of a brief overview of how for loops work. So without further ado, let's get into day 2. Cool. So day 2, woohoo. So we finally made it here. We made it past day 1, which is all the programming syntax. And we're going to get started with an instruction of how to code up some USACO problems. Great. Okay, cool. And today's lesson is when you look at the problem, and whenever you're writing the computer program, you instruct the computer program to brute force the problem, or to literally do exactly what the program tells you to in order to solve it. So let's go over some examples of problems where this is true. So the first problem that we're going to be going over today is a problem called daisy chains. And okay, let me link it into the chat so it's easier for you guys to click. But I'll also post it on the screen. Yeah, so this is a problem. And I'm not sure if any of you guys have done USACO problems before, but a lot of the times what I think is helpful is for you guys, the people who are like sort of trying to learn, is to first read through the problem yourself, then sort of brainstorm ideas for how you think you might be able to come up with a computer program, and then after that, see if you can solve it. Oh, you don't see it. What do you mean by that? Like on the screen, can you currently see the problem that is on the screen? Okay, if you can't see it, I've also posted a link to it in the chat. So if you can't see the problem, think about ideas that you might be able to code up, and then, oh, I see. Okay, sorry. Okay, now it's in the chat. Okay, yeah. So a lot of the times it's helpful for you guys to sort of read it and then read it yourself first, come up with some ideas, and then after that, we'll go over how exactly you might be able to solve it. So yeah, I'll give you guys like about 5 to 10-ish minutes to sort of think about it, and then after that, we'll go over the solution. So I'll see you guys in 5 to 10 minutes. Oh, and if at any point you guys have any questions about something that's going on, feel free to ask, and I will respond to you, and then yeah. Okay, cool. So hopefully you guys have had enough time to sort of think about what exactly is going on. And now I'm going to quickly go over how exactly we can approach this problem. So what this problem is sort of asking for is it's telling us that we have like these flowers, right? So the first number in the sample input tells us how many flowers there are, and then each successive number tells us the number of petals on each flower. So in this sample input, it's telling us that, oh shoot, what on earth? It's telling us that, okay, we have a flower and the first flower has one petal. The second flower also has one petal. The third flower has two petals. And the fourth flower has three petals. And what we want to do is we want to find ranges where in this specific set of flowers, there's a flower that has, there's something that's called an average flower, which is where there's a range of flowers which is a range in which there exists a flower that has an average number, that has number of petals equal to the average number of petals. So what exactly does this mean? Well, for example, the range 1, 1 is an average. The range 1, 1 has an average flower because in the range 1, 1, we're only looking at the first flower, right? And in this range, the average number of petals is literally just 1 because there's only one flower. And as a result, there is actually a flower with this number of petals, which is just itself. So this is an average range. So 1, 1 has an average flower. And for example, if we look at the range 2, 4, this also has an average flower. Because if we look at the range of flowers between the second to the fourth flower, then we see that there's, okay, well, let's first count. What is the average number of petals in this range? Well, this one has 1, this one has 2, and this one has 3. So the average number of petals is going to be 1 plus 2 plus 3 over 3, which is equal to 2. So the average number of flowers is 2. Is there a flower in this range that has 2 petals? Well, yes, of course. This flower has 2 petals. So 2, 4 has an average flower. But on the other hand, if we look at a range like 3, 4, for example. Well, what's the range 3, 4? 3, 4 is this range right here. What's the average number of petals in this range? Well, it's 2 plus 3 over 2, which is 2.5. And is there a flower here that in between? Is there a flower in this range here that has 2.5 petals? Well, unfortunately, no. So as a result, 2.4 does not have an average flower. So hopefully this sort of shows what exactly is going on here. And what the problem wants us to do is it wants us to count the number of average ranges in the problem. So specifically, here the number of average ranges is equal to, so in this case, this is telling us that in the sample, there are 6 total average ranges, and those average ranges are going to be actually 1, 1, 2, 2, 3, 3, 4, 4, 1, 2, and 2, 4. So yeah, these are the average ranges in this specific problem. So before we go on to how we might be able to code this, does anybody have any questions about like understanding the problem specifically? Or just like what the problem is asking, for example. All right. If not, then let's move on to how exactly we can code this up. Okay, cool. So let me clear all these drawings and then move on to this REPL or this. Okay, I'll also do hashtag include vector because we're going to use it. So this is sort of like the compiler that we're going to be sort of coding stuff in. And if we look at the problem, we see that, okay, the first thing that we're going to need to do in any USACO problem is to read in the input. So in this case, for example, there's going to be a couple numbers. The first number tells us, the first number in this case is 4, tells us how many total flowers there are. And after that, there's going to be that many total flowers. sorry, there's going to be that, and then after that, like, so this number is like n, for example, and then after that we have n numbers which describe the number of petals. So let's see how we can start this out. So the first thing that we need to do is read in this number n. Wait, this is n, right? Yeah, we need to read in the number n. And this is so that we know how many flowers there are. So this is pretty simple. We're just going to use cin to do this. So let's say int n, and then cin n. So as a result, now what this command does is we first declare that n is an integer, and then we read in n from user input, which in this case, they tell us that the first number in the sample input is going to be the number of flowers, which is what we need. Okay, cool. So now we know how that n is going to be the number of flowers. Now we need to read in the number of petals in each of the n flowers. And the way that we're going to do this is with a loop. So first, we're told that we're going to have exactly n flowers, each of which has some number of petals. So in order to store the number of petals on our computer, we're going to use a vector, or like a list of numbers. So vector int petals, like this. And this is just declaring that petals is going to be a list of numbers, all of which are integers. Okay, so now petals is going to be a list. So how exactly are we going to put numbers into this? We're going to use a for loop. For int I equals 0, I less than n, I plus plus, we say that int a, read in a, this is a lot of code, and we're going to go through this step by step exactly what's going on. Okay, so what ended up happening was first, we declare that petals is a list of integers with this declaration vector int petals. After that, we run a for loop. What this for loop is going to do is it's going to let us read in every single number of petals on each of the flowers. In this header, we see that, so what this header is basically telling us to do is it's telling us to read in n numbers. The reason for this is because I starts at 0, and then after each time we run the code, we increase I by 1 until I becomes greater than or equal to n. So as a result, since I starts at 0, and after each iteration we increase I by 1, and we stop when I becomes greater than or equal to n, we can see that this code is going to run exactly n times, because I is going to start at 0. After one iteration, it becomes 1. After 2 iterations, it becomes 2, and so on. And when I becomes n, we're going to have gone through n iterations of our code. So we're going to have read in n integers. And specifically what's going on here is we know exactly what this code does. This code pretty much just says we have an integer a, and then we read and we let a be the next integer that the user inputs. So then a becomes the next integer that the user inputs. And now what petals.pushback a does is push back on a list, just adds that integer into the list. So petals is our list of integers, and we're pushing back the number a into our array. So petals we just slowly keep adding the next number into our list petals. And yeah, that's sort of what's happening. So for example, if we wanted to print out all the different, so for example, if we put in our, oh, that's not working. So for example, if we plug in our sample input, let's see what happens. So we first plug in 4, and after we plug in 4, the computer now knows that n is equal to 4. After this, we plug in the number of petals, which in this case we're told is 1, 1, 2, 3. So 1, 1, 2, 3, and then we plug it in. Okay, so our computer output this line of code, which is 1, 1, 2, 3. And essentially what this is telling us is this line of output comes from us outputting this line here. And this is just telling us that, okay, we're outputting the first element of our list petals, then the second element of our list petals, then the third element of our list petals, and finally the fourth element of our list petals. So we're able to see that our computer has in fact successfully read in all of the numbers from petals, and we're able to get 1, 1, 2, 3. So our computer has successfully stored all of the numbers in the petals array. So does anybody have any questions about this part before we move on to implementing the code to solve the problem? All right, cool. So now let's move on to the next part of this problem. So we've now been able to successfully read in the integers into our list of integers petals. So let's see what happens after this. Okay. So now what we want to do is we want to check every single range to see whether or not there exists some sort of integer. Now we want to check if there exists some sort of list or some sort of range in which every single one of these ranges is going to contain an average flower, as we showed here. So how are we going to do that? Well, sort of remembering that, well, one thing we know is that whenever we're checking a range, there's a first number in the range, and then there's a second number in the range. So there's a lower bound and an upper bound. And what we want to do is we want to check every single possible lower bound and every single possible upper bound so that we successfully have checked every single range for an average flower. So the way that we're going to do that is like this. We're going to use this by running, again, more for loops. So we're going to run a for loop that looks like this. And then a second for loop that looks like this. Or like lower, then upper. Okay, so we've now run two loops. And what exactly is going on here? So if we look at this outer for loop, this outer for loop looks sort of familiar. It looks sort of exactly like what we did up here. We declare an integer, which we call lower, and it's going to run from 0 all the way to n minus 1. The reason that this is going to be helpful for us is because this lower bound is going to, so this is the word, the lower variable is just going to represent the lower bound of the range that we're checking, and we want it to run from 0 to n minus 1. And that's why we have this for loop. What about this inner for loop, which talks about upper? Well, this inner for loop so the variable in this inner for loop is called upper, and this is going to represent the upper bound of our, this is going to represent the upper bound of the interval that we're checking. And this upper bound has the special condition that we know that the upper bound is always going to be bigger than the lower bound. So as a result, that's why instead of running upper from 0 to n minus 1, we actually have upper, when we start out our variable declaration, we declare int upper equals lower, because the upper bound is always going to be at least as big as the lower bound. So when it starts out, it needs to start out equal to the lower bound. So that way it keeps on increasing and it'll never be smaller than the lower bound. So we're never going to be checking a case where the upper bound is smaller than the lower bound. So like, for example, doing this stops us from having cases where we're checking the bound like 8, 3. This doesn't work because then the lower bound, which is 8, is bigger than the upper bound, which is 3. But setting int upper equals lower forces it such that the lower bound is always going to be bigger than the upper bound. So we'll always be checking cases like this. Okay, so now inside of these for loops, we have lower and upper. And what we're going to be doing from this point is we now have that So we now have a loop checking every lower bound and every upper bound. So now what we need to do is inside of each of these bounds, we need to check if there exists an average flower. So how do we do that? Well, we're going to split this up into two steps. The first step is calculating the average flower count. The first step is going to be calculating the average petal count among flowers in the range lower to upper. The second step is checking if there exists a flower with average petal count if there exists a flower with petal count equal to the average petal count. And then, if so, increase answer by 1, because that means that this range is successful because there is a flower that is equal to the average flower amounts. And otherwise, don't change answer. Okay. Let's say that, so we're going to say that answer is equal to 0, where answer is the number, and this is the number of intervals that contain a flower equal to average petal count. Yeah. And then we're going to be printing out answer at the end, because we want to print the number of intervals that have an average flower. Okay, and then checking all intervals and this is just okay. So now let's continue with step 1, which is calculating the average petal count among flowers in the range lower to upper. So the way that we're going to do that is by simply summing up the number of petals in the range from lower to upper, and then dividing by the number of flowers in this range. So the way that we're going to do this is as follows, and it's going to be with another for loop. So let's say that the sum, let's declare a variable called sum, which is just going to be the sum of all the petals. And the way that we're going to add up all the petals is with another for loop. We see that we want to find the sum of all the petals in the range from lower to upper. So we have a variable that starts off at lower, and then we stop the loop when this variable is no longer smaller than or equal to upper. And inside of the loop, we continually do sum plus equals petals of this interval. And then, yeah. So then this is going to tell us, so after we run this loop, sum is going to equal the sum of all petals in this range. The reason this is true is because this for loop runs from position I equals lower all the way up to position I equals upper. And every time you run the code inside, sum will add the number of petals in position I to sum, and I iterates from lower to upper, so everything will get added into sum. So after this, sum will equal the number of petals total in the range lower to upper. After this, we want to find the average number of flowers or average number of petals, and the number of average petals can be like a decimal. So say double average petals is equal to sum, which is the total number of flowers, total number of petals, divided by the total number of flowers, which is just upper minus lower plus 1. Because whenever you have like a range like 3 to 8, whenever you have a range like 3 to 8, in the range 3 to 8, there are 8 minus 3 plus 1 equals 6 total flowers. Yeah, so now, so average petals is going to contain the number of petals total in the range. So now we're going to move on to step 2, which is, does there exist a flower with petal count equal to the average petal count? Okay, let's see how exactly we can do this. Now, we've been able to successfully determine that average petals is going to be the number of petals on average in the range lower to upper. So now we just need to check if there's a flower that has that many petals. So we first set like integer check equal to 0. And we say that we change check to 1 if we find a flower that has number of petals equal to average number of petals. So for int I equals lower all the way up to upper again. So you see that once again, we're going to be iterating from position lower all the way up to upper because we want to check all the flowers in the range from lower bound to upper bound. And the condition that we're going to be checking is using an if statement. So an if statement is like, if this is true, then we do something, otherwise we don't. So if average petals is equal to the number of petals at position I, and we use 2 equals in this case, then what we do is we say check is equal to 1 because our condition has been met. Okay, cool, yeah. So sort of recapping what exactly is going on here is we say that average petals is equal to petals I, or like first we're looping over, we want to check every position from lower bound to upper bound to check if the number of flowers at that position, which is here, is equal to the number of average petals across the range. And if so, then we change check to 1 because we've successfully found a flower that has number of petals equal to the number of average petals. So as a result, after this is done, we say that if check is equal to 1, in other words, if we were able to find such a flower, then we increase answer by 1 because that means that this specific range is actually satisfying the condition. So let's quickly see if this works. Oh, for a semicolon here. Okay, wait, something's off. Okay, wait, hold on. Technical difficulties. Can I do something? Oh, this is. Oh, wait. Okay, yeah. So sort of the issue here. Oh, okay, so I'll quickly go over what exactly happened here. So we can see that the sample output is supposed to be 10. Sorry, we can see that the answer is actually supposed to be 6 in this case, except that our thing actually outputted 10, which is a bit more than expected. And the reason for this is because when we did this division here, this did integer division. So if you remember yesterday, when we want to do division and we want to get a decimal, one of the numbers has to be a double. So we're going to change this to a double in order to make sure that the division happens correctly. And hopefully this works now. Okay, yeah, and it works. So I believe that this should get all test cases. Is there a way that I can like, okay, give me 1 second to see if I can log in. Okay, I guess I can open this up in an IDE. Is that possible? Okay, but anyways, in the meantime, as I try to find a way to submit this, does anybody have any questions about what exactly we did here? And feel free to ask however you want, because I know that like we covered a lot of ground really quickly. So you can feel free to ask like what exactly is happening. Whether it be like with a specific part of the code or with a specific part of the question, you know, anything of that sort. Okay, well, it does not seem as though anybody has any questions. So let's quickly submit this to the USACO server and then see if anyone, and let's see if this gives us the right solution. So let's see. I believe I put this in this. So I put it. Okay, so I sort of just saved the file to my desktop, and now let's see if we can submit it and get the right answer. And this is sort of how the USACO server grades. It's just going to check if your computer program outputs the right question. And yeah, so we can see that because it outputs 10 green cases, we can see that we were able to get the right answer on every test case. So the code that we wrote here is correct for this USACO Bronze problem. And yeah, we were able to successfully do it. So once again, if anybody has any questions, then you can feel free to say so in the chat. But if not, then we'll probably move on to the next problem very quickly. All right, it does not seem as though anybody has any questions, so let's move on to the next problem. Okay, so the next problem is this USACO Bronze problem called Shell Game. Once again, I'll post the link in the chat. And I'll give you guys around 5 to 10 minutes once again to think about this and sort of think about how you might be able to sort of solve this problem if you had it. And then after that, we'll go over what exactly to do and what are some different strategies that you can use to sort of solve the problem. So hopefully you guys have had enough time to think about this problem. I'm not sure if I'll have I don't know if I'll have enough time to go over the solution, but I'll quickly describe what exactly is happening in this problem and sort of how you might be able to think about it to code it up. So what's really going on in this question is that pretty much this is we're being told that you have 3 different cups in every iteration. So like you have 3 cups that look like this or something. And under one of them is a pebble. So for example, maybe the pebble is under like this first one. So what's happening is that we're in a starting scenario like this where the pebble is under 1 cup. And then in each of these separate test cases, the numbers described by the first two integers in each line are swapped. So in the first test case, we would swap cups 1 and 2. So this would become this. I guess I'll redraw my cups. And the pebble would move into the second. The pebble would move into the second position. And what the third integer represents is the number that Bessie guesses that the pebble is under. So if this was the case, then Bessie would not earn a point because the pebble would not be under the first cup, which is what she guessed. And pretty much what the problem is asking us to do is it's saying, okay, so across all possible starting configurations, so there's 3 different starting configurations. The pebble can either start under cup 1 like this. The pebble can start under the pebble can start under cup 2 like this, or the pebble can start under cup 3 like this. And it's saying that across all starting configurations, if we're told that the cups in these specific test cases are swapped, and then Bessie guesses that the pebble is under this specific cup, then what is the maximum number of points that Bessie can earn? And the way that we're going to do this is we're going to check the number of points that Bessie earns if the pebble is under the first cup, and then run through all of these cases and check all the swaps. Then we're going to check what happens when the pebble is under the second cup, run through all the swaps and check how many points Bessie would earn. And then finally, check how many points Bessie would earn if the pebble is under the third cup. Run through all the swaps, check how many points Bessie would earn with the guesses, and then we'll take the maximum number out of these and then print that out. And that'll be our answer. And this is sort of like the pseudocode for how you might be able to brute force. So it's like check, check what happens if pebble is under cups 1, 2, and 3. And then for each of these cases, for each case, run through all swaps and see if Bessie guesses right. And then output maximum points earned. And yeah, it's going to be something like this. And in general, the way that you're probably going to do this is with like a lot of for loops. So you can use a for loop for checking what happens for which cup the pebble is under. And then you're going to run another for loop for running through all swaps and then checking if Bessie guesses that the pebble is correct. And then you're going to output the maximum number of points that you find that Bessie earns. And yeah, so since I don't have time to sort of go over all the problems today, I'll just sort of assign these problems for homework for now. So let me clear my annotations. Yeah. So for homework, see if you can do this problem, shell game, which is the second problem. And then we didn't really go over the third problem, but if you have extra time, then see if you can do this problem as well, diamond collector, for homework as well. I think that sort of trying out these 2 problems would be really instructive, and I think that they would definitely be really good. So during next class, if you guys have any questions, then you can feel free to ask about these problems. And yeah, you can feel free to ask about parts of the solution. You can feel free to ask about what the question asks next time. Although we will be going over probably separate material, but just see if you guys can do these problems at home for now. I think it's like, even if you can't solve them in the end, it's definitely still helpful just to still try them, even if you have to end up reading the solution. And you should be able to see the solution if you click like return to problem list and then clicking on the solution right here. And there's like sort of a step-by-step guide for how to solve the problem exactly. So yeah, thank you so much to everybody for coming to today's USACO Bronze class. I hope that you guys learned a lot. And I may or may not see you next week, or I may or may not see you guys tomorrow, depending on if Daniel is here. But regardless, I'm glad that you guys came, and I can't wait to see you guys tomorrow. All right. Yeah, take care, everybody. Bye.